again. Today's lesson we're going to talk about percent composition and empirical and molecular formulas. This is Friday's lesson, March 20th. So first of all, we're going to define percent composition. So what does that mean? So I want you to think of the word composition and what does that mean? So composition would be something is composed of something. So we can say that what something is made of, and then when we add the percentage in there, it's like by what percentage something is made of things. So we are going to look specifically at percent composition by mass, mass being weight, of course. So first example here, so find the percent composition by mass of calcium nitrate. So our first step for this, well, our first step is to think about what is a percentage. If you have a percentage on a test, you're gonna, if I asked you to find the percentage on your test, you take what you got divided by the total number of marks possible, multiplied by 100, and that would give you your percentage. So for this, we're gonna have the same strategy here. So we want to find percentage by mass, so our first step is going to be what is the mass of calcium nitrate. So if I find the full total mass of the calcium nitrate, and so if we do that, we get, what is it? All right, 164.1. So this is 164.1 grams per mole. That would be the molecular mass of the calcium nitrate. So if we want to find specifically the percentage of calcium in that, percent of calcium equals, we can find then the mass of calcium in the entire mass. So we have to use our periodic table for this to find the mass of the calcium. And if we do that, we find 40.1. That's the mass. And that number came from your periodic table. Divided by the total mass. To get it into a percentage, we want to multiply by 100. And so the answer there is going to be the 24.44. So we are going to do the same thing then with the nitrogen and the oxygen. Now, the one thing that's different that you have to pay attention to is that within this molecule, within the calcium nitrate, I only have one calcium, but how many nitrogen atoms do I have? I have 2, so the mole ratio between nitrogen and the whole molecule is going to be the 2-to-1. So I have to factor that into my to my solving for the percentage here. So I'm going to take 2 then multiplied by the 14. The 14.0 comes from the periodic table again. Divided by the 164.1 multiplied by 100, and I get 17.06%. Now for the oxygen, I have to recognize that there are 6 moles of oxygen, or 6 atoms in one molecule, and so I'm going to say 6 times 16 divided by the 164.1, and I get an answer of 50, what is it? I think it's 58.50. Okay, so these are my percentages by mass, and I'm going to use this concept when I'm asked to find empirical formulas, which we'll get to in just a minute. Okay, so now different types of formula. So types of formulae. Formulae is the Latin for, you wouldn't say formulas, you'd say formulae. You change the suffix there. Because we have to be fancy, we have to speak Latin. So the types of formulae here, so we've got empirical formula. I'm just going to abbreviate it EF there. What the empirical formula does is it gives us the simplest formula of a molecule. So it gives us only a ratio of atoms. Well, we know the different types of atoms, but it also gives us the ratio of those atoms to each other. But it doesn't tell us the actual number of atoms in a molecule. It only is going to give us the ratio. So for example, I'm going to have ethane, and the empirical formula for ethane is going to be CH3. So when we look at that, that gives us a ratio. So I know that ethane is made up of carbon and it's made up of hydrogen, and I know the ratio between those things. And so the ratio is I've got 1 carbon atom for every 3 hydrogens, okay? So a ratio, you're just comparing 2 things to each other. So 1 carbon for every 3 hydrogens. Now, if I look at the molecular formula, in contrast, the molecular formula gives the ratio, but it also gives the actual number of atoms in a molecule. So, for example, ethane, in actuality, in real life, ethane is actually C2H6. So I've got 2 carbon atoms for every 6 hydrogen atoms. So if I asked you, what is the ratio of that? You would hopefully say 2 to 6. However, 2 to 6 reduces to 1 to 3. So the ratio is maintained. You can think of this with your math hat on here, and you can think of the empirical formula as being your fraction in lowest terms, okay? So it's like you just reduced it. So you took the molecular formula, you reduced it, and have the simplest form here. So this is only showing the ratio for empirical formula, molecular formula, ratio, and actual number of atoms. Okay, so that is our different type of formula here. Now we are going to, what's next here? You guys have all these notes already, but again, try to just practice and solve stuff on your own. You learn things with the struggle, right? Anyways, one thing I forgot. These two things, we have to think about how they're related. So what we can say is that in this particular case, so what I'm going to say is specific to this example. I can say that the molecular formula is 2 times the empirical formula. Okay, so in this case, the molecular formula is 2 times the empirical formula. Okay, that's going to be important in the next stuff we do. That's why I wanted to comment on it. Okay, so let's work through an example here. So, the empirical formula of a compound is CH2. The molecular mass is 56 grams per mole. What is the molecular formula? Okay, so we're going to take a look at this here. I need a question mark. So the molecular formula is what we're looking for. Now, you're given different information here. So from the empirical formula, what you get from that is the ratio, okay? So the ratio only is what you get from here. So right away, you know that the ratio is 1 to 2. That's given to you from the empirical formula. Now, you're given the molecular mass. So I'm going to make you think, what is the molecular mass? We did talk about this the other day because people forgot. Where do you find the molecular mass from? It's going to come from your periodic table. And the molecular mass is going to be the mass of the molecular formula, okay? So that tells me that whatever the molecular formula is, it is going to have a mass of 56 grams per mole. Now, there are different ways you can solve this problem. If you want to pause and try it on your own, that would probably be a good idea. So pause. Okay, so one way that people like to do it is by trial and error. You have the ratio, right? So you know that it's either going to be CH2. What if I have 2 carbons? How many hydrogens would I have? The ratio is 1 to 2, so this would mean you'd have 4 hydrogens. If you had C3, you'd have 6, C4, you'd have 8, and you'd keep going, right? So what this tells you, the 56 grams per mole, is that one of these is going to have the mass of 56 grams per mole. And you need to just figure out which one it is. So that's one of the ways you can do it. And if you do that, you'll find out that C4H8 is the winner, and that's the one that has the molecular mass of 56 grams per mole. There is another easier way to do it. If we look here, the empirical formula and the molecular formula, we know that they're related by the number 2. And one way to this is essentially what you're looking for. That's what you're trying to solve for here, is how are these 2 things related? This particular example, again, is 2 times. That is not always the case. So how you get that multiple here is what you can do is you can take the mass of the molecular formula and you can divide it by the empirical formula mass. And what you're going to get here then, you're going to get 56 was given to you. And if I calculate this, if I go 1 carbon and 2 hydrogens, that's going to be 14. And you're going to get the number 4. And what that means is that the molecular formula is 4 times the empirical formula. Now, I know what the empirical formula was. It was CH2, so basically I'm going to multiply that by 4 to get C4H8. And that is going to be my molecular formula. So trial and error works. As they get complex though, you wouldn't want to use that method. It would just take way too long. So this is a nice, easy way of comparing them. So you're just, they're multiples of each other. So figuring out how that relationship works. Okay. So we're going to go through an example then on how to find the empirical formula. Okay, so you have this already, but I'm just going to rewrite it here. No, you know what, I'm not, because you have it already. So it says a compound is 31.25% calcium, 18.75% carbon, and 50.00% oxygen. Find the empirical formula. So this question has given you the masses, okay? You have, or the percent composition by mass. You have that information. So you are going to use that information to solve. Essentially, these are just mole ratios, right? So you've got, again, the ratios here are 1 to 2. So that's a mole ratio. 1 carbon for every 2 hydrogens. That's a mole ratio. So what we can say then, if we assume 100 grams, and that's an important step. You know, in math problems, you have to say like, let x equal blah, blah, blah. This is the same sort of thing. You need to set up your problem properly so that people looking at it would understand where your numbers are coming from. So assume 100 grams. And then how I like to do this is I like to set up a little chart because it keeps it all nice and easy and clear. So I've got your element, grams, mole, and then ratio. So these are going to be my headings. Now, in this particular example, you know that you have calcium, carbon, and oxygen. That's what was given to you. So calcium is percent composition by mass, it tells me, is 31.25%. Now, if I have 100 grams, 31.25% of 100 is 31.25. So because I've assumed 100 grams, I'm going to assume then 31.25 grams of that are calcium. The carbon is 18.75, and the oxygen, what was it again, is 50.00. So these are my masses of these 3 elements. Now, when we find an empirical, or sorry, when we find, or when we have a molecule, like we said, these are moles. These are just mole ratios. So if I have grams, can I convert that into moles? Yeah, I can. And how would you do that? You would use dimensional analysis. We're just going to shorten it up because we don't have space on your page. But if you followed the dimensional analysis through, what you would end up doing, you'd have your 31.25 and you'd multiply it by your conversion factor, which is 1 mole over 40.1 grams, and that number coming from the periodic table. So I'm just going to shorthand it here so we have room for it. So it's going to be 31.25 divided by 40.1. That's the molecular mass there. I'm going to do the same thing for the other ones. And if I work out all those numbers, I get 0.7793. And I would carry extra digits here, so don't worry about sig figs so much at this point. You need to carry a few extra to make it work out properly here. And then 1.562. And lastly, I've got 3.125. Okay, so these are moles here. So I need to now find what is the mole ratio between those 3 different elements or 3 different atoms. A ratio is a comparison, it's a division. So what you can end up doing is you can take, how you compare them all is you can divide them all by the same number, and I would divide them all by the smallest number. So if I look here, these 3 data points here, this is going to be my smallest number. So I'm going to divide each of these by the lowest number. So 0.7793 divided by 0.7793, obviously 1. And the next one, I'm going to take 1.562 divided by 0.7793. And you are going to get, I think it's like, is it like 2.0 something, but it's close enough to 2 that I'm just going to call it 2. And then the last one here is going to be 4. It's going to be close enough to 4 that I can round to 4. So now I have the mole ratios of the calcium, the carbon, and the oxygen. So now I can combine those, and this is my empirical formula. Therefore then, the empirical formula, 1 calcium, 2 carbons, 4 oxygens. That is my empirical formula. I'm done. I'm happy. Good. Okay, so that's one example. We'll do another one together. Oh, I'm recording. It's okay. Do you want to say hi? Do you want to say hi, Mr. Mike?
No. I don't know if
What's this?
for watching.
Okay.
You heard of this?
No.
It's got cooking. It's British.
It looks fantastic. I'm gonna watch
It's
that.
like it's one of the best things.
Thank
I've
you.
seen. Enjoy chemistry.
Thank you. Okay, so our next example is going to be, here we are going to take a compound is 43.67% phosphorus. So 43.67% phosphorus. And then the rest of it, 56.33, is oxygen. So you can go through and you can, and then it also, so it wants you to find the empirical formula, but it tells you that the molecular mass of this is going to be 284. So molecular mass is 284 grams in 1 mole. And so you're also asked to find the molecular formula. So we're going to first start and we're going to find the empirical formula. That's always going to be how you approach these. You need to find this in order to find this, because this will give you your ratio. And then you, after that, you can use this to find the molecular formula. So again, we're going to set up our chart. So elements, grams, moles, and ratio. So we've got 2. We've got phosphorus and oxygen. Phosphorus then, oops, oh, I forgot. We are going to assume 100 grams. Don't forget that step. So the grams is going to be 43.67 and 56.33 here. I'm going to convert that into moles by dividing by the molar masses. So 43.67 divided by, what is it, 32.1? No, 31. Yikes. And 56.33 divided by 16. So if I do those, I divide those out, and I end up with, 1.409 and 3.521. Okay, those are my moles. Again, you're going to go ahead and you're going to find the ratios between those. So divide by the lowest number. But now I have a problem, which means you have a problem. You're going to get a 2.5 here. Now, that is too far away from the whole number to round. It's not going to be accurate enough. If you ended up with, say you ended up with like 2.01 or even 2.1, go ahead and round it. Anything more than a 0.1 or a 0.9, you would need to figure out how to do that. You can't have 0.5 of a mole for these. You don't write a chemical equation with decimals in there. So you have to find a way to make this a whole number. So how do you make 2.5 a whole number? You multiply it by 2. So what you do to one thing, you have to do to another. It's just like math. What you do to one side, you do to the other, same deal. So this is going to be 5, that's 2. So the empirical formula is going to be P2O5. Okay, so now that's the first part done. Part B, finding the molecular formula. Now, I want to be able to figure out how is the empirical formula related. So how is the empirical formula related to the molecular formula? So I've got 284 grams per mole is the mass of the molecular formula. So can I figure out what the mass is of the empirical formula? Yes, I can. And so the mass of that, if I add those up from the periodic table, is going to be 142. So now looking at this, if I take the molecular formula mass divided by the empirical formula mass, which is 284 divided by, what did I say, 142, I get an answer of 2. Therefore, what that tells me is that the empirical formula is the molecular formula is 2 times the empirical formula. So therefore, the molecular formula is, I'm going to take P2O5 and I'm going to multiply it by 2. So it's P4O10. Now, if you don't get a whole number for this, you've done something wrong. So say you get, 1.3 there. You've made a mistake and you need to go back. So you've made a mistake in your empirical formula. This has to be a whole number. If it's not a whole number, go back, reassess. You've done something wrong in this section. Okay, so that's it for the empirical formula. I'm very concerned that some of you are not keeping up with your work. We are going to have assessment on this when you come back. And we're not going to wait a whole lot. It won't be the first day or anything, but say we come back on a Monday, on the Thursday, we're going to be having our test on this stuff. So you need to keep up. You need to be asking me for help if you need it. If people are interested, I'll put this up, but if people are interested, we could do like a Google Hangout or something like that, if that's easier for you, but we'll figure that out. Exercise 12 is assigned. The answers are already there. They're in brackets behind each question, so you have the answer key. Please try some of these. That's about it, I guess. See you later. Bye-bye.